Hello everyone, this is Sakshi and I welcome you all to my edutech platform, Way to Learn. We are going to solve problems from mathematical to physics today, and this is going to be the last topic on the mathematical physics, and these topics that I have already discussed, I think they are more than enough for you to uh, gain at least 15 to 20 marks for sure in mathematical physics. So today's topic is from numerical techniques. And first thing, we have to know like what are significant figures. So if I have given few examples over here, so here 123.45. So 123.45 are all five significant figures, and if you have zero in between, they also count. So here in the second example, there are six significant figures, and in the third example, if the zeros are before a number, that is here 0.00465, so the zeros are before any number. Okay, so they do not count. So only here you can say that there are three significant figures, and the zeros that are after a number 123 0 point, okay, 1230.00, they should be counted. So here it means six significant figures. This is just for your knowledge, that if in case you have any sort of questions from significant figures in any way or in a aptitude question, you can use this. Okay, so next is the rounding of numbers. Usually sometimes they can ask problems from rounding of numbers. So if you see here, here 3.14765, I'm not considering the last number, I'm going to consider the number before the last number, so which is 6 over here. So here, if the number which is before the last number is greater than 5, so here 6 is greater than 5, then I will increase the before number by 1. So this is basic rounding off we actually do. So 3.14765 will be written as 3.148. Next is, here again I'm going to see the number which is before the last number, and it is equal to 5. So if any number is equal to 5, then you can again round off to 3.148. So these are the basic two rounding of the numbers. And also if it is lesser than number, then we don't round off, we just write as it is. Okay, so next is 3.14750. So now the last digit is 0, right? And there is 5 is followed by 0, and before 5 is a number which is odd. So for such numbers, we are going to increase the number before 5 from 1, like plus 1. So we get 3.14750 to 3.148. So I hope you get this. 5 is followed by 0, and 5 is equal to 5, so we can obviously round off, right? And also the number before 5 is odd number, so you can round off. And if the number before 5, that is if 5 is followed by 0 and the before number of 5 is an even number, then you cannot round off that particular number, you have to write it as it is. So here is the example for that. So I hope you get how to round off numbers. And these are few formulas which are required in any question. If you have a percentage error or relative error, these are the formulae that you have to find off. And the x here is the original value which is given already, and x1 is the rounded off value which you round off. So these are some formulas. And now next, in the numerical integration, we basically find the integral value here, which is x0 to xn limits f of x dx. And in this kind of integration, we divide the interval into subintervals, like n number of subintervals, and all will have equal size. We can say step size or width. So that width is calculated using h is equal to xn minus x0 by n. You will be given n value or h value directly in the question, so you don't have to worry about it. But if you have given n value, then you can use this formula to find the h value. Okay, so next is the trapezoidal rule, applicable for any value of n. Sorry, that is n. So trapezoidal rule is applicable for any value of n. So n can take any value of n. Okay, and then this is the formula to find the integral value y0, yn. Y0 and yn are the those function. I'll just show you an example how to see that, but just remember this formula first. And then Simpsons 1/3 rule is also given by this following formula, and this 1/3 rule is applicable for even value of n. So when you have h given and you see n is not equal to, like, not an even number, it is an odd, then you cannot use that Simpsons 1/3 rule particularly there. So this is Simpsons 1/3 rule, and Simpsons 3/8 rule is given by this. And this 3/8 rule is applicable for n to be multiple of 3. So n should be a multiple of 3, 3, 6, 9 or something like that. If it is not like that, then you cannot use this particular formula. So I will give you one example for trapezoidal rule, and you can use the same example to check whether it is valid for Simpsons or Simpsons 3/8 rule. So here 0 to 1 x square dx is you have to evaluate this with h is equal to 0.2. So h is given, okay, and you just form a table x and y, and you write the step size as from starting from 0 to 1. You have to write the step size from 0 to 1. Okay, the x values will be from 0 to 1, and the interval should be 0.2. So my x values will be 0, 0.2, 0.4, 0.6, 0.8 and 1. And then y value will be the given function when you apply the x values in that. So y values are given as follows, and these y values are y0, y1, y2, y3, y4 and y5. So you have to always write those once you find the value of y. So now we have the trapezoidal rule and we know the formula for that. I'm just directly substituting the formula over there. So for this trapezoidal rule, you can say that h by 2. Here h is 0.2, so I have substituted 0.2 by 2. And inside the brackets it's y0 plus yn. Y0 here is 0 and yn is the last term, which is y5, which is equal to 1. And plus 2 into all other terms. All other terms are nothing but y1, y2, y3 and y4. So I've added all those and I have got the answer to be 0.34. So you can see the same with Simpsons 1/3 and 3/8 rule. Next important thing is the Newton-Raphson method. In this numerical techniques, I have basically used only the important formulas required for the exam, not other formulas that you would have studied in second MSc. But if you need, you can just go revise your class notes and grasp something more for this numerical techniques. So okay, so Newton-Raphson method is used to find the roots of a function. So you have a given function, basically we equate it to 0 and find the roots. So here if you have like higher polynomials, how would you find the roots? It's somewhat difficult, so we use Newton-Raphson method here. So for that, what are the steps to follow to find the roots? Here is, you have a function and at some point it will be 0, the function will be 0, right? We do not know that point, but you have to choose any two consecutive values of x for which the first value will be negative and the second value will be positive, or for whatever it is, one should be negative and one should be positive. So that is instead of x you are substituting a, and the function gives you negative value, and the next consecutive will be b, and you're going to substitute in the function and you're going to get positive value. Then in between a and b you will have the root of your function. I hope you get this. So next step is is the number f of a and f of b, whichever is closer to the 0 first. Okay, now you have found f of a and f of b, which is one will be positive and one will be negative. So now the next step you have to do is, you have to find, like, you have to see which is closer to 0, which positive value or negative value is closer to 0. If positive value is closer to 0, then that would be the first approximate root. That is not exactly the root, but it is approximate because it is closer to the root. And if the negative value is closer to the root, then that would be the first approximate root. And further roots, approximate roots, can be found using the given formula, xn plus 1 is equal to xn minus f of xn by f prime of xn. So I'll just show you this example so that you can get a clear view of what is Newton-Raphson method. So this is a function, and then first I'm just substituting f of 0, that is I'm substituting 0 and I get 3. which is a positive value, then the next consecutive will be 1. So for f of 1, I am getting -1, which is negative. So now my f of a and f of b are 3 and -1. So in between this 3 and -1, my root will be 0 somewhere, right? There lies some, okay, in between -1 and 3 is a root lying for this particular function. So if you see here, f of x naught gives you -1, which is x naught here is 1. This is closer to 0 than 3. So if you see -1 is closer to 0, 3 is closer to 0, obviously -1 is closer to 0. So my first x naught value will be that particular x which gives me -1. So that x naught is 1. So that is the first approximate root. The next we have to find further roots, right? So next step is to use that formula x n plus 1 is equal to xn minus f of xn by f prime of xn. So here I have taken x naught. So next will be x1 is equal to x naught minus f of x naught by f prime of x naught. That is my formula. So I know what is x naught, which is 1, and I know f of x naught, which is -1, and I also have to differentiate my function and substitute 1 and find what is given. So on doing that, I get my value to be 0.5. So now this is your x2. This is the second approximated root for your function 0.5. So it is more closer to 0 now. 0.5 is even more closer to 0. So now you are going to use that 0.5 in your NewtonRaphson method. That is, now the next formula would be x2 is equal to x1 minus f of x1 by f prime of x1. So you are going to do the following steps for everything, and you are going to find x2, x3, and for how many steps you are going to follow this is until you get similar values, like at least similar 2-digit or 3-digit values, like 0.563. This is your value for some root 563. You have to at least get 0.56, 0.56, 0.56 for once you do all these calculation again and again. So sometimes they given the question directly, like find the roots, like in 1 step or 2 step, and you're going to directly find between 2 values. You don't have to do it until you get the exact value. So next is the Newton's forward interpolation formula. This is the formula for that, and here u is given as x minus x naught by h. And here is an example to find how to use this Newton interpolation forward formula. Okay, so this is your x and f of x is given, and we have to find f of 1.5 here. And you see this first term is x naught, and all other will be x1, x2, and x3, so on. And here 1.5 is x. So according to u is equal to x minus x naught by h, which is 1.5 minus 1 by 1, because your h is here the interval between the x values, which is 1. So 1, 2, 3, 4. Okay. You have you got your u value to be 0.5. Now we are going to form a table x f of x del y del square y and del cube y according to the formula. So here you have substituted x and f of x, and del y is the difference between the lower value and the upper value. So here the lower value will be 7. That is, lower value means the second value and the first value. Second and the first value. Then again third and the second value. That is that kind of difference that you are going to take over here. So del y will give you 7 minus 1, which is 6, 17 minus 10, which is 10, and 31 minus 17, which is 14. And the first term in your del y, del square y, and del cube y will be your del y naught, which is required in the formula. Similarly, del square y will give you the difference in your del y terms, and del cube y will be the difference in your del square y terms. You have to do this until you get 0. Okay. So now I have done this and I have substituted in the formula. When you substitute this particular thing in your formula, you are going to get f of 1.5 is equal to 3.5. So I hope you get this, how to solve problems, and these are like important formulas which are frequently asked in exam. Trapezoidal, Simpsons are most important, and Newton-Raphson method are also asked usually, and this is one of the formula which has the chance to be asked in exam. So I hope you like this video. So thank you. Like my videos, share my videos, subscribe my channel, and also do not forget to hit the bell icon. So see you tomorrow. Ta-da!